Okay, so what is everything that you can tell me about mammals, especially early/origin of mammals? Size-wise, diet-wise, any one of those, or either one of those, or both. Okay, so that is important, and remember, that's just one page. There will be more content to come. And let's see here. So why is that small size important? For two reasons. First of all, when would we picture those animals doing their food gathering? It's not something that you wrote down. It's perhaps something that we verbally talked about. Why is that important? You're right. Right. If there's going to be less predators, there's probably going to be more success for them to be able to stay alive, if you want to call it that. So then, let's see here. What was their diet then? Probably fed on what? It would be an invertebrate, was what we ended up with in the fall semester. What might that be? In other words, fireflies are an example. Dragonflies are an example. Those are categorized, they're not vertebrates, those are invertebrates. Yes. In the same category as mosquitoes. Mosquitoes are what? Those are insects. So they probably fed upon insects at night. And one of the things that happens is sometimes what can happen, okay, is I think I can pull this picture up off of an old presentation. So hold that thought. And I found what I was looking for, and that is sometimes if a trait is popular, it can also go from, let's say, one type of population to that of another, okay? And in this case, this was from the curriculum before the dinosaurs, okay? So sometimes you see aspects that are popular in, again, other populations. And this was an organism that we call the Dimetrodon, okay? And when we say di, the letter D, letter I, meaning two, okay? And the reason that's significant is we're talking about what's called two-toothed here, okay? So even though this was a reptile, okay, it also has a mammalian, the start of a mammalian design for teeth in here for being a carnivore, because not all mammals are carnivores. There's some that are also herbivores. Horses, zebras, cattle, buffalo, all of them have teeth specially designed for whatever their diet is. And in this case, again, it's called two-tooth because it has these very large canines here. So this type of a design was also, let's say, carried and transferred over to the mammals. And that's just a secondary design. The primary one would be what we call here, because they're called synapsids. And what that means is now there is an eye socket, okay, just like what we would picture for that of humans. The eyeball can actually sit inside of a socket like this, okay? Why is that important? Well, it's just a better type of protection for the eye more than anything else. And there's another tribute to early reptiles that is carried over to the mammals, and that is, see if I can find it. Oh, not that one. Here we go. this is also an early mammalian design. Because typically when we look at a lot of the reptiles and amphibians, their legs are more so splayed out like what we had seen here, okay? That's reptilian-like because notice that their legs form right angles. This was an Adaposaurus, and then let's see if I can find that Dimetrodon. Notice that that's not quite a right angle. Those legs are getting further and further underneath them, and that is why we would consider this being an early mammalian design, because look at the legs. They're not forming those close to those right angles in their pelvic cavity, and up here they're standing up taller, okay? So that is also more mammalian-like because, for the most part, are mammals fast? They can be, okay? You might look at, oh my gosh, elephants, they're a mammal, they can't be fast. Well, and I would agree that you're right. You'd have to say within reason, but this early template that was popular in reptiles certainly transferred over to that of the mammals, because one of the things that would happen to become more mammalian-like, the how do I want to say, the metabolism would have to change. Go from cold-blooded or ectothermic to warm-blooded endothermic. And that's one of the things that had happened with that of early mammals. Okay, then when we look at this, we said that they were small and shrew-sized, just like what you put. Okay, it had this enlarged cranium. And what is fitting inside of that cranium? A larger what? You just said it. Brain. Yeah, a larger brain. So one of the things that mammals can do is they can be problem solvers, okay? And for anyone who's ever had a bird feeder would know that when it comes to problem solving, squirrels got a lot of time to figure out how to get to that bird seed. You try to make a squirrel-proof bird feeder, and it's pretty tough to do because, again, even though their brain might not be very big, it certainly has the capability of, per se, putting more space in there, more brain in that small space. Okay? And then let's see here. Moving forward. When we look at mammals, hair and fur, yes. Oh, okay. We attribute this as probably the most recognizable trait for mammals, and that is of hair. See a mistake on there. That is this. Proliferation. What does that mean to you? Google. What is proliferation? Oh, I just saw a handheld device. I thought maybe Google. What is proliferation? Because Google probably knows. Okay. But sometimes we can't always use Google, so why don't you tell me so then we both know? Has something to do with reproduction and growth. Okay, so proliferation means growing by reproducing. Okay, now whether you're talking about rabbits, whether you're talking about rodents, those are what we call very prolific. So there just gets to be a lot of them. So this is rapid growth and proliferation because of hair can actually grow. Not that it grows that fast, but adequate for whatever their living conditions are. Okay, where does that put us? Growth of hair, under hair, and okay. So I want to get through guard hair, then we'll stop there for today. So then when you're talking about different types of hair, under hair is just what it says. It's underneath something. So in this case, what other type of hair would we possibly be talking about? It's not up there. It's something that's on the next slide that we would be talking about. There's actually 3 types of hair. Here we see under hair, which is just what it says, is underneath a different type that's actually above that. And that is what type of hair? Guard hair. That's right. Okay? So one of the things that happens, okay, air is a very good insulator. Okay? And one of the reasons that we would know that, Google. Are we Googling? Oh, okay. All right, I was just curious. Okay. So then, one of the reasons that we know that is due to what are maybe 2 animals that you might see in the Arctic. The polar bear is one, and then there's also a relative of the dog that's up there. It's not a wolf. It's not a timber wolf. Yes, those are maybe in northern Canada, but certainly not in the Arctic. And what do we mean by, there's really 4 ways of looking at canid species. You have domesticated dogs, you had wolves, like we just said, you've got jackals, okay, and then this 4th one is, let's see here, it's only 3 letters long. They're known, they're notorious, which means they're known for being sly. Foxes. Foxes fall under the canid species, just like we said. Wolves, domesticated dogs, jackals, and but not hyenas. Those are more so considered as cats, I believe. Okay, so with that, how can a small Arctic fox live in such a cold region? even though that air current might be really, really cold, you trap that air and use that as an insulator, it will keep them warm. That's why we put coats on, because when you put the coat on, that is trapping that air inside of you. It's also a type of insulator, but actually helps keep you warm then. Okay? And then finally, the guard hair, okay, which is just that. It's above the underhair and provides protection. And there are assorted functions of hair besides insulation, okay? And not only can it provide coloration for identification purposes, okay? I want you to think about perhaps, let's see here, the weasel family, okay, which would include fishers, okay, also wolverines, and then maybe a very feisty weasel that is known as a badger. How do you think you'd be able to tell the difference between a wolverine and a badger? And it's believed that on their anterior region of their head, it looks like they've got a badge there. And that badge is because of different types of color. So that coloration is a way to identify those animals. Then there's also another type of weasel that Pepe the Pew is what type of Looney Tunes animal? It's a skunk. I believe we consider skunks as weasels as well. But how do you know you are looking at a skunk? And you have a black outside with what down the middle? A white stripe. So that coloration can be for identification purposes, okay? Do you suppose you can use hair as camouflage? It might not be for the reason that you might think, okay? So just at random, oh, I thought there was more of them on here. Obviously, you wouldn't be able to get this wrong. This is an ungulate known as a what? Zebras. Okay, so these zebras have different types of striations and the coloration of a zebra. What happens, oops, wrong hand. What happens when you're looking at these is if you have a whole cluster of zebra, they kind of blend in with one another. And why might that be an advantage? It's going to allow them to maybe have that extra little bit of time to evade a predator on the open savanna in Africa. So there's a reason why those animals look the way they do. So they probably started out as either all black in color or all white in color. So then what might have happened is that intermediate changes provided those stripes. Okay, so we'll pick up with new content and catch up to you next time.